Welcome to week 4 of LabView class. In this week, we're going to talk about graphs and charts, time loops, and state machines. So let's get started with the graph and charts. When you build a LabView program and you have your array of data, you may want to see them in a graph and see how they are changing as you produce or generate more data, or as you acquire more data. So that's the part when you use either graphs or charts based on your application. So without further ado, let's get started with the graph and charts. First thing, I'm going to talk about the X and Y graphs, a simple X and Y graph. So you go to the front panel and you right click. There is a function in the control called graph, and they are like different types of graph. I'm going to talk about the X and Y graph first, which are like easier. So let's choose the X and Y graph here, and you can see it also shows in the block diagram. So here in the X and Y graph, you have your X and Y, and it has a label right now as of time. I'm going to change it to X, and then the amplitude, I'm going to change it to Y. So if you go here and go to the properties of this X and Y graph, it will open you the property window, which is taking a while. let's say. Okay, I have to stop this. I'll come back. Okay, here you go. Here is the property window. So if you go to like appear, like you can change so many things in here: the display formats, the plots, the scales. So right now we are on the x-axis in the scales. So you can see that this is showing the major grid and the minor grids. If you don't want to see a minor grid, you can come over here and choose the T. So when you choose the T, it basically deletes the minor grid. And then you can change the color of your major grid to whatever color that you would like it to look like. You can do the same thing for the y-axis. You can delete the minor grid or keep it, have it at different colors, whatever that you like to do. And you can also like here in the display format, you can say like what kind of like numbers do you want to see, like scientific or decimal point. And for the plots, you can choose like if you want to see just like dots and basically nothing, no lines, or you want to see dots and all these things. You can also come over here in this section, right click, and then go to the line style and change the style of the line, or the point style and change the point. If it has a point, change the point. And you can like change it based on whatever method that you want to do. You can change everything, and you can, for example, I want to go with the common plots of like marks and line, and then you can change it. It just depends what you want to do. Now let's say that we want to plot some data in this X and Y graph, and our data, it has to be an array, right? A 1D array of X and a 1D array of Y. So we have like different points of X and Y. So let's go to the front panel and go to array, and then here again choose a numeric control, so because our graph has to be numbers. And then you can it's gonna get hard again here. You can drag it as many points as you want, and I'm gonna call it an X, and then I'm gonna copy the X, and I'm gonna call this the Y. I'm gonna run some random numbers here, just something random. I have no idea how it's gonna look like. But just some random numbers. So we are gonna have 7 points. Okay, so here is our x in the block diagram, here is our y, and we need something to draw our x and y graph. So you can see there's only one node on the left for the x and y graph, so there's no way that you can like connect the x and then connect the y and then draw it. It's not gonna happen. You have to do it another way around. And it is with using bundle. If you remember from last week, if you go to the block diagram, go to the cluster, class, and variant, and then use bundle here. So what bundle does is that it's gonna bundle x and y into some form that the x and y graph can read it and then start plotting the data. So we're gonna connect the x and y to the bundle and then connect the output of the cluster to the x and y graph. So now there's no errors, you can see, so it looks fine. And now let's plot it and see what we'll see. So this is what it plotted. Like, we can double check and make sure the x and y are correct. So x is 1 and 1, the first point, which is in here, and then 2 and 1, and then 3 and 2, and so on. So they look fine. So one thing that you have noticed is that at first the graph, it starts from 0 for the x, but now it's at 1. So there is when you go to here, there is a check mark called auto scale x. So it means that when you are plotting your data, the x will auto scale based on your x value. So if you uncheck it and then run it again and then start it from like maybe 0 to 10, which it was initially, and now let's run it one more time and you can see it's not changing. But if I come here and click on the other scale, it will change it back to whatever, like if the x start from 1 to 7, so it's going to auto scale the x axis from 1 to 7. But if you don't want to auto scale it, just come over here and then uncheck it, and then it will not auto scale. You can define the x and y, the minimum and the maximum for your value, and once you run it, it is not going to auto scale it. So say now you want to change the color of this line and your marker. You can come over here, go and right click and go to color and change like any colors that you want. This is not the best color though. Yeah, you can define any color that you like and make your figure look nice. You can also right click here and then go to line style, as I say, change the line style of your data, and too many different things. You can just get there and then explore the way that you want it to be like. So now let's say that we want to do something with our figure and add a regression, like a linear regression to it, and the upper and the lower value of that of our data. So I'm gonna change this numbers that I have defined so far, so we can do the linear regression with it. So I'm gonna change this to 0, 2, 1, 3, 2, 4, 3, 5, 6, maybe 6, 7, and 7, 8, something like that. So we are having this, and we're going to do a linear regression of these data points. So what I'm going to do is that I'm going to change the way that the plot looks like, so it only have the points, not the number, not the line, sorry. Where was that? Common plots here. So now it's only the points, not the line. And I'm gonna change this also so that it won't auto scale from 0 to 10. And I also want to change the color of these points also. Red, or I don't know, maybe white is the best, like it was before. Okay, so you come over here to the block diagram, you go to mathematics, and then there is a fitting function, and you choose the linear fit. So the linear fit will ask for your y, for your x value, and it's going to produce the best linear fit for you. And it's going to give you the slope of it, the intercept, like whatever information that you want. You can go to the help and explore it more. So the x value, you'll have to connect it to here. No, sorry, that was the y. So the first thing is asking is for your y. So yeah, you have to connect your y to your y, and the second thing is your x, so the x to your x. So it will get the x and the y of your raw data, and it will print the best linear fit for it. So in order to have it in the XY graph, you need to have another bundle. So I'm going to copy and paste this bundle, that this bundle is going to get whatever x value it was from your raw data, but the y value of this bundle is going to be the best linear fit. Because now there is another figure that is going to print, and that's the best linear fit. And then for you to print both of them into one graph, you have to have this graph here and delete the previous line and add these two as an array into the XY graph. As I said, the XY graph can only have one node and can only get one set of data. And I have to make an array of these two bundle clusters and then send it to the XY graph. So you go to the array and then you go to the build array function, drag it one row down because we have two clusters coming into the array here, and then connect it to the X and Y graph. So now if you run this, you will see the linear fit here too. If you want to, you can scroll this one level up and then see the linear line. I like the red line. I think it's the best for this set of colors that we have here, these weird colors that I chose. Yeah, you can see we have our raw data as points and the line as the best linear regression. You can also print the slope and the intercept of this fitted line. So here you can see that we have a slope node and an intercept node. If you create an indicator for each one of them, and then I'm just gonna move them here so it's cleaner. And now if we run, you can see that the slope is 1.42 and the intercept is minus 1.85. It's not showing here, so I'm gonna change this to -5 so we can see like the intercept here, or maybe it's better that I change it to -2. And you can see the intercept is really close to -2, or it's minus 1.85. Say you want to see the root mean squared or r squared of your fitting. How can you do that? If you right click in the block diagram, go to mathematics and then fitting, and this time advanced curve fitting. There is a function called goodness of fit. Choose that. It basically asks for your raw y value, your best fit y value. It will print your root mean square and then r squared and then SSE. So depending on what you want to choose. So connect the y to the raw y value and the best fit to the best fit, the linear fit value here. Because this one gets the x and y and give you the best y with corresponding x. So that's why this is the fit value for you. And then you can print the r root mean squared as an indicator, or your r squared as your indicator. And then you can run it again, and it will show you the r squared. We usually use r squared value as 0.97 of a feet. You can come over here in the linear regression function, and there's the blue node called method. If you right click and then create a control out of it, you can choose what method do you want to choose. Like if you come here, select least square or least absolute residue or bi-square, you can see which method you want to use, and then run the entire thing, and then you will have your new slope, intercept, the root mean squared, error, and your r squared value. You can play with the regression function whatever way that you want, but my point here is how to draw and show your data in an XY graph here. I hope you have understand it so far. I have used the regression example as an example to show you how the graph actually works. Let's go ahead and talk about other forms of graphs. I'm gonna scroll the front panel and the block diagram down, so I kind of have like a cleaner space. So in the front panel, like right click, go to graph and waveform chart, and do it again, graph, and this time waveform graph. So before we worked with X and Y graph, now we are working with waveform graph and waveform chart. In the block diagram, let's use a random number function and produce random number over time, and then plot them in the waveform chart and waveform graph. So in the block diagram, right click, go to numeric, choose random number, put it here, and wire the random number to the waveform chart. Notice if I just run it like this, and look at this one here, I'm gonna produce like one time that I run, and then another run button, another run button. I'm just printing one point at a time with this without any like while loop or for loop. But if you want to see like random number producing over time, you have to put this inside a while loop or a for loop. I'm gonna go with a while loop because I like while loop better than for loop. Just a personal thing. And then for the constraint, create a control so that we don't have errors here, and we are gonna add a wait time of 100 milliseconds, so we can actually see this producing numbers. And now we are going to produce random numbers over time every 100 milliseconds. Basically every second we're going to produce or generate 10 random numbers. Okay, now let's see. So if I stop this and run it again, you can see that it will continue from where it was, and it's not going to clear the graph. And then you can see how it's like shifting towards the right and generating more and more numbers over time. If I stop this and make this 0, you'll see that I have all the numbers. So all the numbers that were generated are kind of saved in the waveform chart. So now let's do the same thing with waveform graph. I'll put it inside here, and I will wire this to the random number. You can see that this is not working, and even the dashed wire line, which is an error, is thicker than this line. That means that the waveform graph needs a 1D array. It doesn't need just a scalar number like this one had. So I'm going to delete this. You can see this is like just one number. That means we need only like a number. We don't need an array. But for the waveform graph, we need an array. I'm sure by now you all know how to create an array. We go to the array, build an array, scroll it one row down, connect the elements to here, connect the other element to the while loop, change it to the shift register, and connect this to here, and we'll have our waveform graph as an indicator of the results. So If you want to delete whatever you have from previous data generation with waveform graph, you go right click and go to data operations and say clear the chart, and you will delete it. Now I want you to closely observe these two and see how the results look like. They should produce the same results. Let's see. You know what? I'd rather change this to 1000 because this is too much for us to compare. And I'm gonna clear this chart again. So just notice one thing. The first thing, this waveform graph deleted. So it starts from the initial. And now I'm gonna stop this. I'm gonna change this to 6. So this will have the same x axis and y axis label so we can compare. You can see they look like they are kind of like mirrored from here. Like in the waveform chart, at time 0 we generated about 0.7, but here at the last time we produced that. And also the other way around, like it's completely mirrored from here. So why do you think that happens? If you remember from previous videos, when we are generating an array here, it will start from top and go to the down. So basically, let me create an indicator here so you can see what I mean. This way is better than just talking about it. So just see how this array is feeling. It's coming down, you can see. So the new elements feel from top and then it comes down. And we have noticed this before. So in the previous video, I wired it this way because I wanted to show you like reversing and transposing and all these things with the array. And doing it that way, I was able to show you more applications and more functions of array, so I could teach you more. But here, now that you have enough information of array, there is a very simple trick that you can basically solve this problem. I'll give you like several seconds to think. It's super simple. Okay, if you want to think more, you can pause this video, but I don't want to just stay here and not talking, so let's get started with that. So with the build function, we are getting the new element on the top row, and then the previous array that was saved will go on the bottom row. So that's why this array is feeling always from top. But if I just delete these two and kind of like switch them, like bring this on top and then the new element on the bottom, then instead of it feeling from top, it will feel from the bottom. So I will also want to create a constant of 0 here so I can delete the array here. Now look at this. The new elements are coming from, like, they are saving down instead of like saving up. So you can see that the new elements will go to the row which is the below the array that already had been saved. On the other hand, for the other way around, when we wired it differently, it always filled from top. Now it's filling from the bottom. And now if I change this, I actually didn't clear this, so I'm going to clear this and I'm going to run this one more time, and then you can see how these two are becoming like similar now. I'm going to wait 14 seconds because this is what it takes, and then you can see how this is the new random number is going to fill on top while keeping the array on the bottom. So you can see how these are now exactly similar, and so the waveform chart and the waveform graph they produce exactly similar results now, while on the other way around, when we wired them differently, they were mirrored. So that's what I want to tell you. The waveform chart, it won't delete, you have to clear the graph. And the waveform graph, basically it needs an array, not a number, while the waveform chart, it only needs a number. And if you want to produce you actually run a waveform graph or waveform chart, you either have to have all your results ready with the time and whatever value that you are measuring, or if you don't have them ready, you have to put them in the while loop. And usually, for most of the case, you need to put them in the while loop, because that's what you do in the lab. You are generating, not generating, but you're basically measuring a specific parameters over time. So you always need a while loop, and then the waveform graph and the waveform chart will be inside this while loop to generate the data. Yeah, so that's what I want to show you. You can see that the waveform chart kind of like updates. Like if I have it auto scales, and then you can see how it's changing. So it basically updates, but this one keeps all the data in. And yeah, that's all I wanted to talk about: the waveform graph and the waveform chart, and basically the XY graph. So XY graph, you could see that you need to have bundle to connect the X and the Y, and your X and the Y are the arrays, and the waveform graphs are different. Again, based on the applications that you have, you can choose either of these graphs and work with them accordingly. For the next video, we're going to continue with time loops, and instead of like generating times with the wait time, we are actually generating real times and see the time that is elapsing. See you soon.